Good morning, ma'am. Good morning, classmates. My name is Daphne Aida Salancho Baliti. I am BT Alpha second year. And I am here to discuss to you about the basic electrical tools in servicing a refrigerator. Number 1, a clamp meter. A must-have tool for a refrigeration technician. This is used to measure the AC current of a compressor with or without refrigerant load. So now I will show you how to use a clamp meter. Number 2 is a multi-tester or volt-ohm meter, a tool used to measure both AC and voltage in the electrical system of a refrigerator. It can be also used to measure the resistance of electronic components in a refrigeration system and the continuity conductivity of wires, lamps, switches, relays overload, protectors, and run windings of the compressor in a refrigeration system. Number 3 is the set of electrical pliers and wrenches, needed in working with the electrical wires in the electrical system of a refrigerator. At least an insulated electrical side cutting plier, long nose plier, and the diagonal cutter plier are available together with some wrenches to work with bolts and nuts. I will show you the set of electrical pliers and wrenches. Number 4, set of screwdrivers, tools that can be used in driving and removing screw. It includes a standard flat screwdriver, a Phillips screwdriver, and an Allen wrench or hexagonal key of a different sizes for Allen or hexagonal screws. Now, I will show you the different kinds of screwdrivers. So, I will also discuss the basic tools and equipment in servicing the mechanical system of a refrigerator. Number 1 is a tube cutter, a device used to cut tubes made of light materials like copper or aluminum covered steel, which usually comprise the refrigerator piping system. It has a ruler, cutting blade, and tightening handle knob controlled by the user to evenly and smoothly clean a copper, aluminum, or steel tube. Now, I will show you how to use the tube cutter.
Now it's got a pretty good groove in there. See that? Oh, and there we go.
Number 2 is flaring tool, a device or tool used to create a flare, a 45-degree enlargement of the tip of a tube similar to the opening of a jar. Refrigeration technicians use this tool in making charging port for charging refrigerant into the unit. This is usually a two-piece tool composed of a flaring block and a flaring yoke. The block is a two-metal assembly which can be tightened or loosened using wing nut bolts in both ends and provide with holes or slots for different sizes of tubes.
Slide it down to where you can open it up. Bring it up where it's flush with the top, and then slide this down. Once you get it in position, tighten it up in the right spot. It goes down into the copper. Now you spread this up. That keeps it from pulling apart and opening up where it can slide down and then start flaring. Now once it starts clicking, it's not pushing in anymore. Open it up to completely clear, loosen up, slide back down to the end so it'll open up, and you have a beautiful flame.
The number 3 is a swatching tool. A swatching tool, a tool used to enlarge one end of a tube where another tube of the same size is to be inserted and braced or soldered to create a tightly sealed joint. This is a punching metal device of various sizes used with a flaring block where tubes to be swatched are mounted and held firm. It is then inserted and punched gradually to shape the tube ready for fitting the other tube of the same size.
Top cancellation tool and squeeze the handle until the tool completely closes. Repeat this process on the other side. Thank you for watching.
The number 4 is silver brazing equipment. Produces a very hot bluish flame used in making charging ports and joining two pieces of swage tubes. This equipment can be an oxyacetylene, a blowtorch, and a portable propane torch.
Brazing and soldering are similar processes to each other. Both involve the melting of a filler metal to join two or more components without melting the base material of the components. In this video, I'm brazing copper to copper using a 15% silver alloy filler metal. It melts above 1400 degrees Fahrenheit. Very basic process. It's a stronger joint than if I were to solder this particular joint together, and that's desirable for the build quality and use of the joint.
Number 5 is system analyzer. Uses channels in vacuuming and charging refrigerant into the refrigeration system. It consists of a manifold with 3 service intake ports with hoses of different colors, usually red, blue, and yellow, that can be coupled to a 4-inch fittings as connections to other equipment like the vacuum pump, charging port of compressors, and the refrigerant service tank. Atop the manifold are 2 gauges. I will show you the 2 gauges. The number 6 is a vacuum pump. Used to remove air, moisture, and dirt before recharging to a refrigerant in a refrigerator system. This process is known as a vacuuming, which is a must when the seal piping system is open during servicing.
Another electrical tool in servicing a refrigerator is the refrigerant service tank. This is a refrigerant container used when servicing a refrigerator or air conditioner. This is usually connected to the compound gauge when charging the refrigerant to the system. Last tool is the refrigerant. This is the recovery equipment used to recover or unload the refrigerant from the refrigerator to be serviced instead of just letting it out in the rain. This equipment is needed for a safe disposal of refrigerants. So now let's tackle the planning and preparing for troubleshooting and repair of domestic refrigeration. Students in refrigeration and air conditioning or a beginner technician needs to understand some basic troubleshooting guide before attempting to perform refrigeration servicing. Being familiar with the different electrical and mechanical parts and knowing how they function in the system is a helpful knowledge and skill toward being exposed to hands-on troubleshooting and servicing. As a technician progresses in the craft, he or she has to go through a continuous learning process. He or she should continuously read books and manuals to do some research and talk with the experienced technician to update himself on the development in his or her field. The advent of the technological advancement like computers, electronics, and even digital technologies have been applied in refrigeration and air conditioning. Hence, there is also an immense need for the technician to improve and adapt to these changes. According to the Garupa and Magalayman 1994 and the revised edition of How to Repair Refs and Freezers, presented and practically discussed some sequences to follow in troubleshooting and refrigeration problems. Aside from the 2 major systems, the electrical and mechanical system, they included 2 other factors to consider in troubleshooting, which is, they call them as the four distinct areas of trouble. So first is the external factor, second is the electrical section of the refrigerator, third is the mechanical section of the refrigerator, and last is the hardware on cooling. Now let's move on to the troubleshooting by section sequence. As stated that the refrigerator's normal operation depends on the condition of the four sections, diagnosis or troubleshooting should also follow a sequence as illustrated in the following block diagrams. Common complaints of customers boil down to any of the following sections. Visualizing diagram in figure 42 will tell you that the operation of the refrigerator starts from the power source at home, particularly the AC outlets where the refrigerators are plugged. The electrical section operates to activate the mechanical section to enable the cooling agent or the refrigerant to circulate in the system and produce the required temperature and pressure, and the hardware comprising the cabinet and compartment to ensure maximum efficiency and maintain the product temperature. The technician follows the sequence in doing the repair work, taking into consideration not only the flow and presence of refrigerant and current but also the characteristics and test points to find the trouble. Each of the section is composed of the different parts. Likewise, these parts are to be diagnosed in sequence except for the cabinet hardware. The power source starts from the electric service provider, the community that is connected to the main fuse box or circuit breaker in the house, then to the section fuse box or branch circuits to the other AC outlets, and finally, the refrigerator's convenience outlet. Upon confirmation that the power trouble is not caused by the external power source, it is not time to look into the electrical system of the refrigerator. Considering that the technician is already familiar with the electrical connections of the different parts of the components of a refrigerator or air conditioner, troubleshooting is it by sequence will facilitate the job. The block diagram in figure 43 will serve as the technician's guide. The presence of connect voltage in the electrical system will make the testing easier if there is current flowing in the circuit. Otherwise, the use of test instrument like VOM or AC voltmeter will give conclusive information about the status of the electrical system. The testing procedure starts from the power cord to the switch and overload protector, then the starting relay before going to the motor electrical winding. Next is the mechanical section of the ref unit arranged in sequence. Troubles in the tube system. Take note that the flow of current in the electrical system ended in the motor winding. The electrical system that is composed of sealed piping and tubes of different sizes serve as the passage of the coolant or refrigerant that circulates in an entire system to produce cooling or no cooling at all. Likewise, when the refrigerant escapes or leaks out from the system, it is either there will be a reduced cooling or no cooling at all. Troubleshooting by touch of the mechanical section of the refrigerator. Experienced technicians use the sense of touch in diagnosing the cause of problem. A normally operating refrigerator produces temperature levels in different tube systems. Some tubes are hot, some are warm, and others are cold. A discrepancy in the temperature level means that there is something wrong in the system. The diagram in the figure 45 will guide you on the expected temperature in a particular part of the mechanical system. This is also distinguishes the high side and the low side of the system. Troubles in the electrical components. Determining or diagnosing troubles in the electrical system of the refrigerator is easily done using some of the test instruments like VOM or the comp meter to monitor the presence or absence of voltage or current flowing in the circuit. Conductivity or continuity in the contact of switches such as the thermostat switch, the overload protectors, and release are done using the ohmmeter while measuring alternating current needs and ohmmeter or clamp meter for some extreme cases measuring the resistance. In figure 46, checking the current starts and run when winding the motor is done using clamp meter using ohmmeter. The presence or absence of voltage is or current flowing in the circuit is the only parameter considered in the troubleshooting in electrical system. Removal or replacement of the defective component is usually remedied. Troubles in the mechanical system of a refrigerator. Unlike the electrical system that the absence of power will cause the system to be inoperative, the mechanical system is a bit complicated. The cooling agent or refrigerant may be present but produces poor cooling or no cooling at all. The main characteristic of the mechanical system it is a tightly sealed system composed of a series of tubes of various sizes connected with one another forming a cycle. This is passage refrigerant and oil that circulates in the entire system. These are the discharge line, the condenser tube, the liquid line, the filter, the capillary, evaporator, and accumulator, and the suction line. When this seal is broken, refrigerant escapes out from the system. This is called leak trouble, which may produce partial or no cooling at all. If this happens, the technician needs to find out where the broken part is being performing leak testing. Another trouble in the mechanical system is the clog trouble, which means that the refrigerant meets an obstacle in the process of circulation that it cannot pass through. Both the leak and clog trouble results the abnormal temperature in the entire system and manifests poor cooling and no cooling at all.